The purpose of this video is to demonstrate how to find the area of a trapezoid. Now, a trapezoid is a quadrilateral with exactly one pair of parallel sides. Now, a quadrilateral means that it has four sides, and two of those sides are parallel. That means that if those sides were to be extended for infinity, they would never intersect. They would always stay the same distance apart for all time. Now, here's an example of a isosceles trapezoid. Now, when you see an isosceles trapezoid, you're probably not going to see a line like this. I put this line in a few moments ago to demonstrate what a height line would look like with an isosceles trapezoid. We call this an isosceles trapezoid because it has two sides that are primarily, well, they're congruent. Like if this was 20 meters, this would be 20 meters. Now the sides that are parallel, the sides would be this one. We call it base 2, and we have this line here, or line segment, because it does end, base 1. So we have base 1 and base 2, and those are parallel, and then we have these other sides that are not parallel. If these two lines are parallel and the other side's parallel, what we'd wind up with is a parallelogram, a rectangle, most likely. But it has exactly one set of parallel lines. Now, this line is most necessary for showing the height when you're trying to find the area of an isosceles trapezoid. Now there's another kind of trapezoid that you're likely to see quite a bit of, and I call this one a right trapezoid because one of the sides, this side here, looks like it does double duty. Not only does it serve as the side, but because it's perpendicular with base 1 and base 2 here, it also tells the height of the trapezoid. Now, I've had students before who for some reason they just cannot understand that you could possibly have a side that serves as the height, and they'll go in and they'll actually try to draw another line segment to represent the height. Well, you don't need to do that. If this side forms a right angle, this will serve as your height. You don't need to put in another one. Okay, now let me clear my board and we'll go ahead and do a couple examples of how to find the area of a trapezoid. Now, the formula for finding the area of a trapezoid is area equals 1/2 times base 1 plus base 2 times height. Now, with this isosceles trapezoid, we're going to have to include a height measurement in order to solve for the area. I'm going to say base 2 here. I'm going to go ahead and say that its measurement is 20 meters. I'll say base 2 here. I'll make its measurements be 25 meters. I'm not even going to put a side length because we don't need side lengths unless we are doing parameter. And in that case, we would add all the sides measurements, and that sum would give us the parameter. We would not include the height if we were figuring out parameter, but we are solving for area, so we need to know that height and not these sides. So the height, I'm going to just go ahead and make it 20 meters as well, just to make it easier for us to do the math. Now, area equals 1/2, and base 1 is going to be 25 plus. I came very close to putting a time sign there. I've been making videos showing the areas of triangles and parallelograms, and got a little bit mixed up there for a second. So 25 plus 20. And then the height is 20. So let's go ahead and solve this one out. So 1/2 times, and 25 plus 20 we know is 45. And then we'll put 20 here. Now, just a moment ago, I was observing the rules for the order of operation. I was doing what was in parentheses first. And now, I would usually go from from left to right because it's multiplying all the way through. But if I try to multiply 45 by half, I'm going to wind up with a decimal, and I don't want a decimal right now. So because of the associative property of multiplication, I can do whichever combination first and still get the same product. So instead of saying half of 45, I'm going to say half of 20. So I'm going to say 45 times, and half of 20, or half times 20, is going to be 10. And then all I have to do now is just say 450 meters squared. So that was just a neat little trick, just kind of help make the math a little bit easier on you if you're not using a calculator and you want to do this stuff quickly. Alright, let's go ahead and look at another example of how to find the area of a trapezoid. Here we have a right trapezoid. Now, we know it's a right trapezoid because we got a 90-degree angle little symbol here, so we know this side is serving double duty. Not only is it a side of this trapezoid, but it is also the height. And we'll say that this one, we're going to be working with a big tall building. We'll pretend like this is a huge building, and we're going to say that this building, now by the way, I'm from southeastern Kentucky, so for me a huge building is going to be like 90 feet. That's a tall building, 90 feet. And base 2, we'll say base 2, we'll say it's 100 feet. And we'll say base 1 here, we'll go ahead and we'll call it 110 feet. And we don't really need to know this side because we've got all the information we need for our formula for area. So area equals 1/2, and base 1 is 110 feet, plus base 2, which is 100 feet, times the height, which is 90 feet. So area equals 1/2, and 110 plus 100 would be 210 times 90. Alright, 1/2 times 210 is going to be 105 times 90. And 105 times 90 is going to be, well, let's go ahead and work this out. 105, and here's 90. Okay, I'm going to put a placeholder. $9,450 feet square. So that's the area of this right trapezoid. I hope that this video has been helpful to you understanding how to find the area of a trapezoid. If you use this simple formula and plug in measurements for those variables, use the order of operation by doing what's in parentheses first, and then whatever else then you want to do, because it's associative property multiplication. If you want to multiply this sum by half, or if you want to multiply the half by the height first, it'll work out. Alright, I hope this video was helpful. Thank you.